So hi everyone, thanks for coming today. So we are going to have a presentation of Alephium by Cheng Wang and an alumni from EPFL. So pretty nice. So welcome and you can go for it.
Yeah, thank you for the introduction. Since there's no microphone, if my sound is not loud enough, just let me know. Yeah, I'm very glad to be here to give a quick introduction to Alephium, to share with you guys what is Alephium and why it's great. So first, a bit quick introduction of myself. I came to EPFL to do research in 2013 in the distributed computing lab, working on consensus algorithm research. So that was back in 2013, and like blockchain still was not very big thing. I was mostly doing pure theoretical research. And in 2015, I proposed the first linear time asynchronous Byzantine agreement algorithm. I came from like very research theoretical background, and then I found that I'm more interested in practical systems. I love coding. I love engineering. So that's why I went for industry after 2.5 years in the lab. Since 2018, I started work on the project Alephium. It's a innovative blockchain I'm going to describe. So the first very important question is, why do we need a new blockchain? Why did we create Alephium? I first go through a little bit about blockchain. Why do we need blockchain, right? Blockchain is a decentralized technology to remove the centralized entities from the global transaction system. The first very important feature is decentralization. The second thing is security. It's actually not trivial to have a global ledger that's nobody can easily double spending, right? And this is breakthrough based on consensus algorithm and cryptography. And the blockchain has a lot of applications with these very, very, very great features like openness, transparency, efficiency, ownership, and privacy, etc. You can get a lot of those nice features in just one system. That's great. But blockchain is not easy. It's actually very, very hard. Since Bitcoin, blockchain has been more than 10 years. We have seen a lot of new blockchains coming out every year. And still right now, I don't think we solved the problem, right? Still a lot of open problems to be solved. And you can see that there are many teams right now try to make the blockchain more efficient, more accessible, more secure. So from the very theoretical or very, very deep look, you can see that there's actually a trilemma. You cannot really get everything out from a single blockchain system. You have to make trade-offs between scalability, decentralization, and the security. But that's actually not all. You have a lot of more to consider if you want to build real systems. For example, like you need to care about latency, throughput, networking, and the storage, etc. There are so many things to consider when you try to build a very practical blockchain. As I said, that there have been more than 10 years development for blockchain. What is the current state, and what things should we improve? First, Bitcoin is still kind of more or less the same as 10 years ago, although the ecosystem actually is much better technically speaking, Bitcoin is still the Bitcoin is 10 years ago, and it's very solid. And that's really cool. That's really cool. You mostly in most of the times you don't see any issues with Bitcoin network. Only a few times actually. And then this second very large ecosystem is the Ethereum ecosystem. It also has been like almost 10 years. Actually just past 10 years, I think. And right now, Ethereum try to scale with layer 2, right? Everyone knows that they have been doing this for many years. But I think since this year, people see a lot of issues with this approach. This text here is a bit extreme, but it actually showcases the problem. Right now, the layer 2 solutions are mostly very centralized, and you have actually they kind of don't contribute too much to the fee of the layer 1. So people say that this actually kills the network effect of Ethereum, right? Kills the layer 1 because they absorb users liquidity from layer 1, also transaction fees. This is another more technical breakdown of the layer 2 issues. So basically, it says that the cost to run layer 2 actually is quite huge. It's not like you can just click and deploy a layer 2. Actually, you have to spend a lot of money every year to maintain, the network. And this is another direction that people are trying to improve the blockchain is try to build high performance blockchain. The most well-known example is Solana, and also Near, for example. But they have the problems. The most well-known issue is that the hardware requirements for running the blockchain is actually very extreme. For example, here is the hardware requirements for Solana validators. If you check it, actually it's a bit crazy, right? You need huge amounts of memory. You have very high-end CPUs to rise. This is going to limit the decentralization of the network because it's quite expensive to have those servers and to maintain to operate these servers. You need special skills. So definitely it's not great for decentralization and not good for security. Actually, a few days ago, Vitalik comments on this type of centralization issues. For a lot of new blockchains, actually, they only talk about speed, they don't talk about how to make it more decentralized or more censorship resistance. So this is definitely an issue, right? It's kind of going a bit derailed from the origin of blockchain. Another observation is that right now, all of the new blockchains are using proof of staking. But actually, in my opinion, proof of work still is very relevant and still have a lot of potential. First, proof of work is very simple and has been really well tested by the industry, like since Bitcoin. Since you guys here are, computer science background, that it's kind of very easy to implement it, right? And also very easy to test it. You probably can do it in like less than 1 hour for a prototype. This is really great because it's very easy to, you can trust it very easily, right? And then proof of work actually scales much better than proof of staking, proof of stake, because it's more stateless. You don't need to manage all of the validators on the blockchain. So actually managing the validators is non-trivial as a consensus algorithm. There are many different types of proof of stake algorithms, and they have different trade-offs. They both, all of them are because the challenge of managing validators on the blockchain. Third, the token distribution model of proof of work is very different from proof of stake. Proof of stake is basically it's kind of people describe it as rich people get more rich. You have more token, you stake it, and you get more token. This is like one of the issue with this is it's not good for innovation. You know, once you have like especially for the private sale, they got a lot of token with at very cheap price, and then they are not motivated to innovate. But proof of work is quite different. The token distribution is more permissionless and more kind of friendly for the newcomers to the ecosystem. Lastly, proof of work suppose multiple proposals by default, and this is sorry.
Yeah, I just had a question. So proof of work has some advantage, but how about energy efficiency? Because like chains like Bitcoin and other proof of work chains do work great, but they sometimes consume a lot of energy, which is like not quote unquote useful, because like Bitcoin is just mining SHA 256 hash, like for quote unquote nothing. Like it's used for like a secure the chain, but it's not like useful energy consummation. So
that's definitely a good question. It's a very common critics against proof of work. So first, I think proof of work has improved a lot. The ecosystem improved a lot in the past. I think a lot of mining is using green energy. I'm not very familiar with that topic, but you can easily find a lot of good articles on that. The second, actually, we have ways to improve that. We are going to talk about that in the following slides. Yeah, so definitely that's one of the disadvantages. The last one what I want to mention is that proof of work suppose multiple proposals by default. If you are a bit more familiar with the consensus algorithm, you know that proof of stake usually is lead based. So it goes epoch by epoch, and then each epoch there's or each round there's a lead that send the message or transactions to send the message or blocks to the other peers. This comes with some issues when it comes to DeFi, because like MEV is much easier when you just have one leaders every round. But proof of work is different, because every round you don't know who is going to be the lead. So yeah, as you can see, proof of work has advantages, and right now there are not so many blockchains on proof of work anymore. So we believe that there's a huge potential in this direction. So here's a quick summary of the current state. First, Bitcoin is the most robust crypto network. It has been running flawlessly for more than 10 years. And Ethereum is also great. It's the first smart contract platform, and try to scale to make it more performance. And one of the nice thing about Ethereum is that the core team, the foundation, they do value decentralization. Like I personally criticize Ethereum a lot in the past as well, but they do value decentralization, and the Vitalik and the core devs, they try to scale it without too much sacrifice on this dimension. But the layer 2 scaling solution definitely has issues, as we see in the recent years. And the many new blockchains, they focus on performance, focus on speed, don't really care too much about decentralization or security. So yeah, here we see an issue, because we basically want in my opinion, what we really want to have is a more performant blockchain that is still cares about decentralization and security. Basically, we want to have something that's Ethereum want to achieve, but has not been done yet. So that's basically what we want to build with Alephium. First, we want to scale the blockchain, but we want to scale it without sacrifice the core value of blockchain, right? So we want to follow in Bitcoin philosophy. Second, we leverage the Bitcoin tech stack. Right now, most of the blockchains, they focus on proof of stake, focus on account model, but we see great value in proof of work and great value in UTXO model. And the last one is Bitcoin is great, but it doesn't have a good programmability, so we want to bring that to the Bitcoin stack as well. That's what we want to do, and actually we have achieved that. So I'm gonna talk about how we achieve that to achieve the 3 goals. First is the scalability. It's actually the starting point of everything. Back in 2017, I started to have this idea to improve the scalability of Ethereum. Actually, I started by focus on Ethereum. I tried to follow the sharding roadmap of Ethereum since 2016, and then I have some ideas in 2017. I come up with a new algorithm called BlockFlow. It's a sharding algorithm. So basically, I was not very happy about with the sharding algorithm of Ethereum, and then I tried to come up with a new one. That's called BlockFlow. It's very different from the proposal by Vitalik. In the Vitalik or original sharding roadmap, they use proof of stake, but we use proof of work because proof of work is, as I said before, is more scalable. You don't need to manage the validators. We do it with UTXO model, and this is also great because UTXO model is more immutable, and immutability is great for parallelism. You have computer science background. You are very familiar with this. So BlockFlow algorithm is very it's compared to the Ethereum approach is actually much simpler and much easier to implement. We managed actually to have the first prototype in 2019. At the same time, actually, if you look at the history of Ethereum sharding, it took them, I think, 3 to 4 years. Still, they cannot finish the roadmap. Yeah. So this is really great. And we don't have a master chain. In most of the sharding design, you have to have a master chain that try to coordinate all of the shards. That's actually is not good for throughput. At some point, the master chain is going to be a bottleneck. But in our design, there's no such limits. Another innovation is in our sharding algorithm, the cross-shard transaction is very efficient. You just do it in a single transaction. This is much better than the current other sharding algorithm.
Yeah. Are you gonna discuss about this single-step cross-shard transaction later, or?
No. Feel free to ask right now.
So, does it slow up the? I mean, they need to synchronize the shards. So, does it slow up the process, or how does it work?
So that's actually a good question. So synchronization is part of the consensus. And the consensus is based on the structure of the blocks. So the blocks is not a chain anymore. It's actually a DAG. We have multiple blockchains, and the chains, they have dependencies on each other. And each chain can make progress without being blocked by the others. So in this way, you don't you have the liveness, basically like the classical blockchain. You have liveness, but with proof of work, you favor liveness over safety. So you always make progress. So it's the same in our case. All of the chains still can produce new blocks without being blocked by the others. And then the consensus algorithm will select the DAG with the maximal weight. So it's the same as you select the chain with the maximal with the heaviest work. So this part is the same. So in the end, you get algorithm that still favor liveness over safety, so you still don't get blocked.
Okay.
So basically, you have to, for any consistent algorithm, you have to make trade-off between liveness and safety, right? And proof of work favors liveness over safety, and the proof of stake usually favors safety over liveness. So here you don't get blocking because it's liveness favor algorithm. Yeah, so the algorithm is much more simplified, like much more elegant, easy to implement, and we managed to actually to have that in 2019. But that's not the whole story. You know, if you with this, it basically means we already scale Bitcoin. You know, we have multiple blockchains running based on the Bitcoin tech stack. But because we are a new blockchain, if it's just a blockchain for making transactions to transfer tokens, that's not enough. So we want to do more than that. That comes the programmability for Bitcoin basically. As I said, that in 2019 actually we have the sharding algorithm, and then 2019 is a great year. It's the year of DeFi. We see a lot of new innovations in the application space. For example, MakeDAO, Uniswap, Compound, they start to basically to boom, right? Also, we see a lot of new DeFi concepts, DeFi projects being tested on Ethereum, right? We see significant growth in TVL, in total value lock. It means more and more money into the space. At the same time, we see a lot of challenges as the DeFi grows over the years. The first and the most well-known challenge is the security of DeFi. Like right now, every week, every month, we see a lot of hacks, right? On-chain hacks for DeFi projects. And the projects and users, they lose billions since 2019, like multi-billions actually. So this is definitely a huge issue that needs to be solved. And the second issue is scalability. Yeah, if you remember, like in 2019, 2020, actually the transaction fee was a bit crazy when some of the protocol launched. This is the first transaction fee, and the second thing is the blockchain state, they start to grow. If you look at the Ethereum blockchain, if you're familiar with the Ethereum blockchain, actually right now the state access is one of the bottleneck, right? Because it's blockchain is usually based on Merkle tree, and Merkle tree is quite a slow data structure, especially when it's used with database, right? The third very well-known issue is user experience. Yeah, like crypto is very, very new, and DeFi is even younger, and DeFi is complex as well. So it's actually quite a high bar for newcomers to really enjoy the tech. So we actually, because we are a young blockchain, we kind of observed the progress and the evolution of DeFi. So we try to build a new model so that we can really mitigate or address all of these issues. And that's why we propose a new model. It's called a Stateful UTXO model. It's actually a combination of the UTXO with the accounts model. So if you like a bit familiar with the take of blockchain, you know that there are two main like ledger models: UTXO model and the account model. Account model is very good for programming, like it's used by Ethereum, and the UTXO model is used by Bitcoin. So first I talk about a little bit about the advantage disadvantage of both. UTXO model is very good for security, and is very immutable. Like users have full control of over the assets. You know, if you have the assets in UTXO, if you don't, if your key is not liquid, you always only you can access the assets. So this is really very, very secure. But the problem with UTXO is it's very hard to program with it. It's not so intuitive. On the other hand, account model is very familiar to the classical Web 2 model. You can use it just like the typical programming models. But the problem is the security is a big problem because everything is kind of secured by smart contracts somehow. And when you in a lot of cases, you actually have to trust the smart contract to manage your assets, right? And in that case, it's not that great because if there are some bugs in the smart contract, your wallet can be jammed, right? So that's the issue. So we try to combine both together to get the advantage from both, right? Get the security from UTXO model, get the scalability from UTXO model, and get the programmability from the account model. And one thing I want to highlight, sorry, go ahead.
No, okay. Oh, okay.
Please.
So, for example, if there is a smart contract on Alephium,
yeah.
How does the UTXO model protect the user?
So first, for example, in the DEX, that depends on the implementation of smart contract. Let's take a DEX as an example. You always have the access your token at your wallet, but this is still pool. But that pool is protected by the UTXO that is controlled by the contract. Of course, here in this case, if the logic that's managed the UTXO has some issues, you may lose the tokens in that pool. But your own tokens should it's not going to be impacted. For example, LP token, if you add liquidity to it, you get LP token. The token is in your own wallet. It's not in the smart contract. But in the EVM model, it's kind of still managed by the contract. Yeah.
Okay, so it is like an immutable implementation of a token that is, trusted because of how it works, and so no one can spend those tokens without your key.
Yeah. So it's kind of like that. So this example actually have a pool. In some cases, you don't even need to have a pool. In that case, like even if the contract have some bugs, you may not be affected. But actually, even when there's a pool, there's still, because of UTXO model, you still have a more protection and the less attack surface, because you know which is the weakest part. The weakest part is the pool UTXO. So you just need to make sure that the code that is related to the UTXO, you try to harden it as much as possible, and then the security is good. But with the smart contract model, is really very tricky. With the account model, it's very tricky. Yeah. Another advantage with UTXO model is you can have native assets with the UTXO model. Right now, if you look at the EVM, actually the asset is not native, and that's actually creates a lot of issues in building application. Also introduce a lot of attack surface. So in our case, tokens are first-class citizen. This is very convenient. Yeah.
Is it similar to the standards that Solana has for tokens, or?
I checked last time. It's quite different. Probably a bit more similar to the more close to the Swiss model. Swiss, they have object model, and that's why it's more immutable. Okay. But Swiss, they have their own issues in their design. we are a bit more kind of try to get the benefit of both. But I believe Sui and the Aptos, they make different different trade-offs. Yeah, so first we combine both models together, and the second big change we make is we make transactions actually is following the input-output mode of UTXO. This actually limits a bit the kind of the programmability of the virtual machine. But what you get is you won't have re-entrance attack issues. You won't have flash attack issues. This here is actually a trade-off, because flash loan has its use cases, but we choose to like disable it by default to get higher security.
So you say that there could not be flash loans on Alephium?
Yeah, exactly. It's
and for example, there is someone like really rich and puts their money in a pool, and anyone can borrow the money. I mean, I don't know how it works in the transaction on Alephium, but so there wouldn't be a possibility for someone with like the logical smart contract to borrow the money in the same transaction, do some stuff, and give it back.
Yeah, that's exactly why we introduced this input-output model. So basically, in your use case, actually, the transaction actually has multiple transactions in a single transaction, right? But in our case, it's impossible because the input-output model, each transaction has to be standalone.
Okay.
So basically, we decompose the kind of the assets, the flow of the assets into multiple phases, and each phase has to be a single transaction. And in this case, if you want to do flash loan, you have to do it with multiple transactions, right? And then in this case, it's like people can arbitrage it, and it's more risky. So in this way, actually, it breaks a lot of those like similar things like flash loan is not possible.
Okay.
So definitely it's a trade-off here, It's limited somehow, but we do it on purpose for higher security. So, it's a bit more like Bitcoin, favor security over the other stuff. And still you can do most of the well-known DApps. And last thing, I'm not sure if it's relevant, but basically UTXO model, you usually have the concurrency issues because it's immutable, but we don't have these issues because we combine both together. So we have new model, then we cannot use EVM, of course, because EVM is a full account model. So we have to build a new virtual machine for the new model. It's totally non-trivial. If you familiar with UTXO, you know that's actually building a virtual machine for UTXO is already very hard. If you want to build a new virtual machine for UTXO plus account model, nobody has done this before. So it took actually us quite a few years to finish this. So we built a new virtual machine. We started this from 2019, and then we launched the network at 2021, right, if I recall correct. So it's 2 years development for the first version, but the first version was very limited, and then it took us like 2 network upgrades to make it really powerful and flexible enough. So that's the context. But at the high level, we built new virtual machine to work with our new Stateful UTXO model. Here's a few highlights of the virtual machine. First, it's very efficient. As you all know, that EVM is very, very slow. Right now is the main bottleneck of the whole execution engine. So from the first day, we focus on performance. Execution is much, much faster than EVM. And also we make the bytecode format very, very compact. Here we have an example. We actually implement the same smart contract, same wormhole bridge contract in RAF, in our programming language, in our virtual machine. And the backcode is 10 times more efficient than EVM and 1,000 times more efficient than Solana. I don't know why Solana is bridge contract is like 1 megabit, but yeah, we are much more efficient here.
By bridge contract, you mean like a bridge application between, like for example, Ethereum and Solana, Ethereum and Alephium, and
yeah, we fork it wormhole. You know the wormhole bridge. We fork it to add the support for Alephium, and then we compare the same contracts. So basically, we implement the same logic.
okay.
So we can. So this is a fair comparison. You know, we actually did the same comparison for Uniswap, and actually the difference is kind of similar. That's very interesting. And for Uniswap, like our bytecode size is also like almost 10 times smaller. Yeah, this also contributes a lot to the efficiency. And then we introduced a new system called the asset permission system into the virtual machine. This actually can solve the token approval issues of EVM. Right now, you know, like on EVM, like token approval is a huge issue. Like if you click on some, you know, malicious links, the hack state can drain your wallet, right? Because you approve the people to use your token. But in our case, it's impossible because we have this asset permission system. So every transaction, if you want to use the assets, you have to get approval on demand. Like if you want, for example, like for this transaction, I only use 1 Bitcoin, then I only approve 1 Bitcoin. You cannot, the hackers, they cannot steal more. But on Ethereum is a bit different. Like usually you have to approve, like you just basically approve like the contract to use all of your tokens, and that is very dangerous. Also, we focus on storage efficiency. We implement a storage renting mechanism in the virtual machine, and in this way, we can kind of have a mechanism to mitigate the state bloating issues. We also have a sub-contract system. This is very new. It's basically a system to make to kind of very similar like the Web2, the web host system. You can use this system to locate smart contract much easier. Basically, to index the smart contract with the more semantics. Yeah, that's so. We have a brand new virtual machine, and that's not enough. We need a language for people to build on top of it. So we did not stop there. We built our new programming language. It's called Rust. It's basically Rust plus Alphred. We took a lot of inspirations from Rust, from Scala, and from Solidity. Yeah, Scala because we are from EPFL, right? So Rust is a domain-specific language to build in the apps on Alephium. It's designed to work with the Stateful UTXO model. From the first day, we try to make the language as simple as possible. Right now, you see a lot of blockchains, they use Rust for the app development. But in my opinion, or Rust or Move, right? But in my opinion, Rust or Move, the learning curve is actually pretty high, right? Rust probably you take 1 month to learn about it, to learn the borrow check, to learn all of the stuff. That's definitely not practical for a lot of developers. Similar for Move, in my opinion. So we try to keep the language as simple as possible. I think that's why Solidity got main adoption in the past, because it's really easy to use. But the main problem is security, right? So we keep the language as simple as possible. At the same time, we try to keep it very secure. So security is the #1 priority as well for us. We have introduced many innovations in the language to make it very secure. For example, we introduced annotations for mutability, for asset usage, for external call. I think for mutability, this is also done in Move, if I recall correctly. But for external core, I think we are the first language to do that. Basically, the compiler they can check if the cause is secure or not. And actually, it's unsafe external core is one of the root cause of many attacks. So this feature is really great. Also, we have a lot of built nice security features that is enabled by default. And the language is DSL. It has a lot of features to use to interact with the virtual machine with the blockchain context. So we have a built-in virtual machine, built-in functions for VM interaction, for smart contract creation, and for events. And most importantly, we have a syntax for the APS system, for the asset permission system. You can see in the second one, you have the braces, and then you can approve the tokens on demand. This is really cool, very secure. You just approve the exact amount of token you would like to use for the function. You won't allocate more. Yeah, to give you a bit more sense about how the language looks like. So here's the code for the DEX. It's the swap function, basically the same function as the Uniswap. The first box you see a few like annotations. Basically, an annotation says that we want to use the assets from the users. We want to use the assets from the smart contract. And this function, you don't need to check the caller because this one swap function users have to provide access. You don't need to check the permission. You don't need to have admin for this function. And then the second box, we have a much simpler syntax for conditional checking, and also very efficient. The third box is about how to move the assets. So you see there are like two types of ways to move the asset. You can move assets to the contract. You can move assets from the contract to the users. And the last one is the last box, red box, is the emit syntax. So basically, it's a way to emit logs. But in Alephium, the log system actually is very different for Ethereum. For Ethereum, all of the logs are actually on the blockchain. That's not really efficient because it's going to make the system make the blockchain very bloated in the long term, right? And it's also very expensive. In our case, the events they are not logged by default. So only if you enable it for the 4 nodes, you're going to see logs in the database. Otherwise, it's not really use any resources. So it's very efficient. I think there are some companies they try to. Oh, sorry. Go ahead.
Can you finish because maybe the question is about that.
Okay. Yeah. I want to say it's like there are some companies on EVM they try to do this. I forgot the name. It's called Shadow Logs. They try to do that, but the problem is for the existing blockchain contracts you cannot remove it, and also because it's not a built-in feature, you have to rely on a third-party company to do that. It's not that decentralized. Also, it's not a very cost-effective.
Yeah. My question was, since you make it conditional to store logs in the node, do you also make the opcode or whatever you use for emitting logs much cheaper, or?
Yeah, it's much cheaper. Yeah, the gas cost is much cheaper compared to EVM. So the gas wise is also more efficient. I think this definitely is great and definitely necessary because most of the firms on the blockchain, they don't really care about the events, right? And why do you need to store it on the blockchain? Yeah, so that's basically quick introduction of the language of the whole virtual machine, the whole stack. If you are interested in, give it a try. we have very good resources. We have tutorials on the documentation. We have lots of templates. You can visit the website, and we focus on developer experience and the user experience a lot. Actually, since the mainnet launch, like from the first day we launched the mainnet, the user experience, the dev experience is very bright, and then we spend a lot of time improve this. Like now, I have to say that it's very friendly, and a lot of our community developers, they really speak very high of this. I personally write a lot of smart contracts in the past. I try also different type of blockchains. Like it's not really easy. So we try really to meet like eliminate these kind of issues in Alephium. But still, we have a lot of work to do. So if you have some time, join the ecosystem. We have a lot of bounties and grants on this as well. Actually, it's not Alephium is not just about scalability, not just about smart contracts. We actually have a new algorithm to improve the energy efficiency, and the great question I asked you before. So proof of work is using a lot of energy, of course. Even if like right now it's using a lot of green energy, still like somehow if you can reduce the energy consumption, it's gonna be great, right? So that's why we come up with this algorithm called proof of less work. Basically try to reduce the energy consumption by moving some of the costs in the physical world to the network costs. So I think I should speed up. Pizza is coming. Proof of less work. We find a way to make the miners when they mine the network, they don't just spend energy. They also need to burn the coins. So in this way, it's kind of they do physical mining and the virtual mining at the same time. And the virtual mining, you don't need to spend the energy. You don't need electricity. So in that way, you can reduce the energy consumption. But we still need to spend some energy. However, it's a huge improvement over Bitcoin. With the current setup, actually, we can, with the current parameters, with the same network condition, we can be like, we can use as less as like 1/8 of the energy of Bitcoin. So it's already huge. Okay, so that's all the technical deep dive. So if you have questions, I'm happy to answer.
I'm sorry I missed the proof of less work, but can you just tell me how it works?
Yeah, so at a very high level, is basically in Bitcoin mining, the miners, they spend energy, right, to mine the Bitcoin. But in our case, it's the miners, they spend energy, and at the same time, they need to burn the coins in the network. So it's part of the work comes from the electricity, and part of the work comes from the burning of the coins. So in this way, you kind of have a physical mining and the virtual mining in parallel.
Okay, but let's say Alephium becomes #1 blockchain. How does it work then? I mean, will it have the same problem as Bitcoin in the end, or?
So with this, the algorithm can be parameter. You can configure the parameters. So with the current parameters, with the same network condition, we only use 1/8 of the electricity of Bitcoin. So it's way more efficient.
And how does coin burning works?
Coin burning, basically, you in the UTXO model, you put your coins in the input. That's basically it's going to be burnt.
Okay, but I mean, do you burn it when you provide the block with your hash solution, or is it like a continuous process during
It's
the
per
block
block.
mining, or?
It's per block. It's
Okay.
in the Coinbase transaction.
Okay.
So that's the transaction you get rewards. So you're gonna do
But so you burn coins and you get rewards, but so then hopefully for them they get more rewards than coin burn.
Yeah. So there will be a equilibrium based on the formula. But if the reward is zero, then basically no miners will work on it. So then the hash rate will drop, and then you're going to get the equilibrium. But it's the same as Bitcoin right now. If you keep increase the hash rate, then basically the cost to mine a new block would be the same as the Bitcoin value, and then in this case the profitability is zero as well, right?
I think I see.
So it's a dynamic. Like if there's no profit, then the hash rate will basically drop down, right? This is actually what happens when the price go down a lot, and then miners they have to shut down the rigs, stop the machine because it's not profitable anymore.
Okay.
So yeah, mining actually is quite interesting. It has a lot of dynamics. I heard that is, from what I heard, is a very dirty business. But that's actually makes it more decentralized and more robust somehow. It's kind of counterintuitive. Because like for proof of staking is like, it's so, everybody knows how to run, a lot of companies knows how to run the validators, and then it becomes centralized because, it's so easy to scale it.
Yeah, I mean, there is really a high benefit of centralizing scaling facilities, but there are still like as the same for ASICs mining as well. Like it centralizes in low electricity prices countries as well.
Yeah, but actually it's more decentralized because you cannot get unlimited electricity from one place, right?
Yeah.
You have to distribute this. But for proof of staking, as you can see with Lido,
What if we get a fusion reactor?
That's a good question.
When you become massive.
Just a question. Does Alephium provide some kind of privacy on protocol level or on chain level?
So we right now, like, there's no built-in privacy for that, but you can build on top of it. You can build, for example, like CoinJoin, like Bitcoin. You can also have like pool-based privacy as well, like the EVM one. Tomato. Yeah, you can build. Also, I think in the future we're going to introduce more more cryptographic primitives into it, and then you can build more with those ZK stuff.
Yeah.
So it's possible. Sorry, go ahead. Yeah.
So, given the trade-off you've mentioned with the UTXO model, do you think you can match DeFi or on the EVM, where you can have a loan against a pool, then you can switch the collateral with the flash loan, or gain leverage to the flash loan? Do you think the Alephium is capable of matching its functionality?
That's a very good question. So lending is buildable, but the feature you described probably is not possible. Like I think it's called, I forgot the feature. The name of the feature is called.
Scale on flash loan, or
basically, it's using flash loan to swap the position, right? But that's why it's not possible. We have to make this trade-off, get security, but sacrifice a little bit of the use case. Yeah.
Aren't you afraid that, like, given these limitations, people would build around them, and instead of using the native UTXO model, they would switch to a fully account balance based model just to circumvent this kind of limitations somehow, or that wouldn't even be possible?
That's definitely possible. As you said, you can use account model to simulate everything, right? I don't think it's going to be that good because it's not natively supported. It means that you want to build it, you have to build your own infrastructure for it. You have to build your own indexer for it. That's very challenging actually. That's actually, I think, one of the main issue of the inscription system right now. Yeah, like you have to build your own infrastructure for it, and it's not really scalable for the long term. Like it just become a thing for a few months, and then nobody cares about it. Yeah, but actually we are thinking about to introduce a little bit limited support for this kind of special use cases. We are still researching about it. So probably for this, lending protocol, they could have new primitives to support that. But we are researching about it. It's a very interesting topic. So last we want to talk about the kind of the ecosystem development stuff. And the mainnet was launched in 2020. We have the sharding algorithm, like when the mainnet was launched. We have the first version of the virtual machine and the language. We have the SDK, we have the wallets. And then, the first version was very ready to, too naive, and it's not really usable somehow. You can use it to issue tokens, but it's not powerful enough. And then we launched this the first network upgrade. It's called the Lemon upgrade, and it's actually a huge evolve from the first version. And with this, we can build bridge, DEX, and the NFT marketplace. And the language improved a lot as well. SDK is much better, and we introduced a lot of standards. And then this year, we made a new upgrade. It's called Home Upgrades. We reduced the block time. We introduced more more features to the language, make it more developer friendly. We released the first version of the SDK finally. So what is the current state right now? Alephium is still a very young project, and still kind of under the radar. If you look at the market cap, it's not really in top 100, even though I personally believe that we are very innovative, and we believe we can be there at some point. So right now we are the second. We have the second TVL among all of the proof of work blockchains after Bitcoin. Because right now most of the TVL are on the proof of stake blockchains, but in proof of work side we are actually pretty big. We have a bridge to Ethereum, and soon we are going to bridge to the other blockchains. We have DEX, NFT, and quite a lot of things where I'm going to talk about that very soon. We have very successful first hackathon. We attract almost 100 community developers, and it's very organic. It's the whole growth of the whole ecosystem is very organic. We have a lot of JSCs. One last thing I want to mention is that the hash rates actually increased a lot in this year. If you look at the numbers, 100 times more than earlier of this year. So ecosystem, we have a lot of things right now, even though we are still quite young. If you are interested, you can check the website. We already have quite a lot of things. For DeFi, also right now, lately we have a lot of hard wallet support. So the security is quite great as well. We have very good infrastructure, Explorer, Oracle name service, we have games, and more applications come like DEX, stablecoin, and the lending protocol. Okay, so I think that's sorry, go ahead. Okay.
I don't know.
Thanks.
Is this the end of the presentation?
No, I still have a little bit things.
Okay.
That's the basically. You have a question?
Yeah, one quick question that I had is, have you ever considered making Solidity, for example, compared to Alephium just to get some extra to reduce the friction to onboard new developers, or like is this something you doesn't have to be Solidity, maybe some dialect of Solidity or something?
Yeah, that's a question actually. Quite a lot of people were asking and talking about in the past in our Discord. There's a dev actually trying to do that. But I personally don't think it's really much possible. First, the Solidity model is quite different from our model, so it means that you cannot really translate everything, and then you probably waste more time by doing that. And the second thing is, our model is different. It means for some or certain things, the best practice is quite different. Like for Ethereum, you have to consider a lot of those security or attack surfaces, but in our case, you don't have this. Then you have more freedom to implement it differently, right? And also I believe that for smart contract development, probably the implementation is not really a problem. The most tricky part is the security. So like the translation part does not really help too much about the security. So that's the kind of the finish my introduction of Alephium network. But for this meetup, I prepared something for you guys. Since EPFL have a lot of talents, I prepared this little puzzle for you guys to crack it. If you have some time, you want to have some fun, you want to know how the blockchain virtual machine works, you can try to open this website. Try to find the answer. If you find the answer, don't hesitate to reach out to us. There's some reward in the contract. Is 100 ARF. It's not much, but if you manage to crack it, probably if you want to do an internship or so don't hesitate to reach out to us. What I can promise is like working with us is very fun, and very challenging as well. If you want to do something very challenging, and we code with Scala, with Rust, with TypeScript, whichever language you want to use, you can have a fit.
That's really nice.
Yeah.
Thank you for offering.
Thank you very much.
Yeah, that's it. Thank you.